Good morning, students. Yesterday I have finished with tangents and normals. The topic tangent and normal was finished yesterday. Now I will be taking up curvature. To explain the curvature of a curve, let me consider two curves. Let there be two arcs, PQ and P dash Q dash of same arc length, say S. Arc length is same. Length of the arc is S, is also of same length S. One can observe that this curve bends more sharply than this curve. And we say this curve has more curvature than this curve. This is obvious, one can see it. But how to say it mathematically? Let me tell you how to say it mathematically. Let me draw two tangents. This is one tangent. This is another tangent. One can see, let me suppose that this angle is psi. And again, let me draw two tangents at the same distance. The way these two have been drawn on some distance, I'll be drawing these two tangents and let this makes an angle psi dash. One can see this psi is greater than this psi, although length of the arc is same. So we say this curve has more curvature than this curve, and we say average curvature of this curve is psi by s, and average curve of this curve is psi dash by s. So greater the psi, greater will be curvature because s is fixed. You have fixed s. So curvature depends on this angle psi. So we can see that the way tangent rotates along an arc, here also defines the curvature. So this is arc rate of rotation of a tangent, or rotation of a tangent along an arc is known as the curvature. Fine. So this is curvature. This is the average curvature, average rate of bending. You can say average rate of bending. Right? Okay. Now let me find curvature at a point. So if this is a point, say P, then what will be curvature at one point? Now, let this be the curve. And let me suppose that length of this curve is S, and this is a point P. I have to find curvature at this point P. Okay. Let me draw a tangent on this curve, making an angle psi with the initial axis. Fine. Now let Q be the neighborhood of this point. While drawing tangent to the curve at Q, which meets initial axis at, say, this point, making an angle psi plus delta psi over here, then this angle will be delta psi. Exterior angle is sum of the interior opposed two angles, so this will be delta psi. So if I have to find curvature at this point, then let me say, okay, average bending is the same. Okay, one more thing. Length of this curve was S. We are moving from P to Q. This is the neighborhood of this point P. So there will be change in S, which is delta S. Likewise, when you are having point P X Y, if this was the point neighborhood X Q, then this is X plus delta X, Y plus delta y. There is increment in x, y. Similarly, when there is s, you are moving from s to p to q, there will be increment in s also. This will be delta s. So average bending, you know, it will be delta s by delta psi by delta s. So what is curvature at point P? See, let me suppose that since I have to find curvature at point P, let me suppose that Q approaches to P. When Q approaches to P, delta S will approach to 0. So limit delta S approaching 0 will give us the curvature at this point P and is denoted by K. So K curvature at a point is given by d psi by ds. The reciprocal of this curvature, reciprocal of K denoted by 1 by rho, rho is called the radius of curvature. At point P and is given by rho equal ds by d psi. So I will be using this one or this one in my future references. So curvature at point P is given by d psi by ds. Fine? Okay. For example, if I have a question, say S is equal to C tan psi. What is the radius of curvature? Radius of curvature ds by d psi is C sec square psi. This is rho. Your rho is ds by d psi, C sec square psi. Or if you can elaborate it further, secant square is 1 plus tan square psi. You know tan psi is s by c. So c 1 plus s square by c square. You can write it in this form, in this form, in this form, or in this form. C square plus s square by c. This is the radius of curvature. Okay. Let me take one more example. S equals c log of secant psi. Find the radius of curvature. So let me differentiate with respect to psi. ds by d psi. C log of the function, 1 by function, secant psi. Then derivative of secant psi tan psi. So rho is c tan psi. This is okay. So this is quite easy. If you have a relation between s and psi, obviously you have to differentiate once, you will get the radius of curvature. Okay. Fifth things, I am not elaborating it over here. You have already the book with you. You can see what is the circle of curvature and how do we come from this K to this rho. How this is taken as reciprocal of the curvature. What is center of curvature? What is circle of curvature? You will read it yourself. Main thing is this. Now, in terms of Cartesian coordinates, what is the formula in terms of Cartesian coordinates? If you have point P, x, y, what is the radius of curvature? Our article is that find the radius of curvature for the curve, find the radius of curvature for y equal fx, means Cartesian form. Or you can say that, show that, or prove that radius of curvature rho for the curve y equal fx is 1 plus y1 square raised power 3 by 2 divided by y2. Now how to conclude that radius of curvature for the Cartesian curve is this. Let me show you. See, this is the tangent to the curve at P and this is angle psi. We know, you know from 12th, tan psi is dy by dx. Okay, you know this. Fine. Our dy by dx is what? It is y1. So psi is what? It is tan inverse y1. What is y? Y is function of x. So what will be y1? It will be a function of x. Now let me differentiate this with respect to x. D psi by dx. What is that? Tan inverse function 1 upon 1 plus function square. Derivative of the function with respect to x. What is that? y2. Okay. So d psi by ds dx is equal to y2 upon 1 plus y1 square. But what I am aiming at, I have to find the rho, radius of curvature, and radius of curvature is in terms of s and psi. So I will be, psi is there, I don't have s. Now, or this is d psi by dx, d psi by ds, ds by dx is equal to y2 upon 1 plus y1 square, right? Instead of dx by d psi by dx, I have written d psi by ds, ds by dx. This is the chain rule, you know already. Now, what is d psi by dx? D psi by ds, it is k, or it is 1 by rho. Dx by dx, ds by dx is equal to y2, 1 plus y1 square, or what is rho? Therefore, rho is equal to, take rho here, it is 1 plus y1 square divided by y2 ds by dx, or rho is equal to 1 plus y1 square y2. Now, what about ds by dx? This is under root of 1 plus y1 square. Now how? This is ds by dx, which is 1 plus y1 square. You have already been taught this one in terms of in 12th class. So I will presume that you know this. Or let me show you this way. This time for another articles I will not be showing. See, if you have P of xy here and Q is the neighborhood of this point, this is x plus delta x, y plus delta y. This you know. Now, you see, this is the point xy, so this will be x and this will be y, right? There is nothing to worry about. Now, this is the point q xy, so this will be this, from this to this will be x plus delta x, so this is delta x. Because this is x, this is delta x, right? Total is x plus delta x, right? Now, this is y, but this will be delta y. This is delta x, this is delta y. Remember again, this was s, so this will be delta s. Fine? Okay? Let me show it again so that it's clear to you. This is P, x and y. P, x, y. Okay. This was s. From this to this is s. As shown in my first, when I started, I told you that this is fixed s and this will be q, the neighborhood. This is x plus delta x, y plus delta y. Now, obviously, if this is the origin, this is x, this is y. Simple. Now, if this is y-axis, then this whole thing is y plus delta y, and this whole thing is x plus delta x. So, means this is delta x. So, if you are drawing this parallel to this is delta x, This is y as per here, and this is delta y. This is delta x, this is delta y. Obviously, this will be delta s. Because this is s, this is changing from p to q. So, using Pythagoras theorem, this is delta s square, which is under delta x square plus delta y square. So, delta s is under root of delta x square plus delta y square. You can take delta x outside, 1 plus delta y by delta x square. Right? Okay? We have the triangle. Delta x, delta y, delta s. So delta s is under root of delta x square plus delta y square. Taking delta x outside, this is 1 plus del y by del x whole square. Now this is delta x, s by delta x, which is under root of 1 plus delta y by delta s whole square, right? This is what I have written. Now taking limits as q approaches p, because you are actually taking curvature at point p, while p is function of x and y right now, because we are taking the Cartesian coordinates only. So this will be ds by dx, and this is 1 plus y1 square under root. Fine? That is why I have used ds by dx is equal to 1 plus y1 square. So finally what you are getting is that your rho in terms of Cartesian coordinates is 1 plus y1 square is power 3 by 2. 1 plus y1 square raised power 1 by 2 plus 1 divided by y2. This is it. Okay? So if you need to find curvature of radius of curvature for a Cartesian curve, then you have to find y1 and y2 and substitute in this formula. For example, say you have xy equals c square. This is a Cartesian curve. It is in terms of x and y. So what is y? Y is c square by x. So let me differentiate with respect to x. What is y1? C square by x square. This is actually c square x is power minus 1. Derivative of x is power minus 1 is minus x is power minus 2. So c square by x minus c square by x. What is y2? This is actually c square x is power minus 2. So it is minus minus plus twice c square x is power 3. Fine? Minus 2 x is power minus 3. So you have y1, you have y2. What is rho? Rho is 1 plus y1 square raised power 3 by 2 divided by y2. This is 1 plus what is y1? C square by x square. So c4 x4 whole square raised power 3 by 2 divided by y2. What is y2? 2 c square by x cube. You can keep it likewise, or you can simplify it further. Okay? This is it. This is radius of curvature. If a point is given, say you have to find radius of curvature at a point, say 1, 2, 3, 4, 5, 6. So you have to substitute values of x and y in order to get a particular value. Okay? Now let me take up one more question. Say you have x cube plus y cube equal to at 1, 1. Find the radius of curvature. Find rho. For this curve, x cube plus y cube equal to at 1, 1. This is a Cartesian coordinates, Cartesian curve. So let me differentiate with respect to x and y. This is 3x square, then 3y square and y1 equal to 0. So what is y1? Y1 is minus 3x square by 3y square. So minus x square by y square. Fine. So what is y1 at 1, 1? It is minus 1. When you put x equal to 1, y equal to 1, it is minus 1. Now let me find y2. minus you can take outside. This is u by v now. y4. Y square as it is, derivative of x square is 2x minus x square at is it? Derivative of y square is 2y y1. Fine? So 2 you can take outside, minus 2. This is xy square minus y1 x square. You can take, okay. This is okay. 2 I have taken outside, other rest is there. Xy square, x square, y and y1, y4. Now your x is 1, y is 1. And you know y1 is minus 1 at 1, 1. So y2 at 1, 1 is minus 2. X is 1, y is 1, so it is 1 minus y is 1, x is 1, y1 is minus 1, so it is plus 1 divided by 1 is power 4. So it is 2 into 2 minus 4. So y2 is minus 4. Therefore, the radius of curvature. Hence, rho 1 plus y1 square raised power 3 by 2 divided by y2. This is 1 plus y1 square is minus 1 square is 1 plus minus 1 square is 1. 3 by 2 divided by minus 4. Or this is 2 raised power 3 by 2 divided by 2 raised power 2. I am omitting minus sign because this is the radius. I am taking only positive sign. So this is 2 raised power 3 by 2. 2 raised power minus 2. So this is 3 raised power 3 by 2 minus 2. So 2 raised power minus half. Right? 2 raised power minus half. So rho is 1 by root 2. To be precise, radius of curvature is 1 by 2. Fine? Likewise, you can solve any question if it is in terms of x and y. Let me take one more question. See, if you have ellipse, these are semi-conjugate diameters of an ellipse. You have A of lengths A and B. Then this point will be A cos theta, B sin theta. And this point will be minus A sin theta, B cos theta. This you have already been taught in your 12th class. So let me find curvature at this point, P. And let me suppose that this is P dash. Now, so let me take the question at curvature at P. At P. What is P? A cos theta, B sin theta. So your x is A cos theta, y is B sin theta. This is the Cartesian form. What you need to find is y1 and y2. So let me differentiate with respect to theta. Dx by d theta is minus A sin theta. Dy by d theta is B cos theta. Therefore, dy by dx is again chain rule. Dy by d theta by dx, B by A cos theta. Cos theta by sin theta. Okay. This is your y1. Now differentiate. Let me differentiate with respect to theta. Again, I will get y2 minus B by A. Derivative of cot is minus cosecant square. Theta. Now theta is function of x. So d theta by dx. So this is minus B by A or B by A sin square theta. And what is d theta by dx? It is minus 1 by A sin theta. So it is minus B by A square sin cube theta. So you have A, y1 as well as y2. So you can find rho. Therefore rho Rho is equal 1 plus y1 square 3 by 2 divided by y2, 1 plus b square by a square, cot square is cos square theta, sin square theta, raised power 3 by 2 divided by y2 minus b a square sin cube theta. Fine? Or you have a square sin square theta, b square cos square theta, 3 by 2 divided by a cube b cube, a cube sin cube, because it is a square sin square raised power 3 by 2. 2 cancels out, what remains is cube into a square sin cube theta by b. I am again omitting minus sign because this is the radius. So you have it. So radius of curvature at the point P is a square sin square theta plus b square cos square theta raised power 3 by 2 divided by AB. Similarly, you can find radius of curvature at this point. And there is a relation, there is a question on this. If CP and CT are the center radii of curvature of an ellipse, then you have to prove something. Say rho 1 raised power 3 by 2 plus rho 2 raised power 3 by 2 is equal to a square plus b square by ab raised power 2 by 3. You will do it yourself. This is it. Okay, now let me come up with Cartesian polar form. Radius of curvature for polar curve r equal to f theta, or radius of curvature for this curve r is f theta is r square r1 square raised power 3 by 2 r square twice r1 square minus rr2. R is function of theta. You can find r1, r2. You can also find multiplication of r1 and r, r2 and r, and substitute. Okay. Now, how to solve this question? How to find this formula? I will be showing this rest. There are two more formulas. One is pedal and one is polar tangential form. You will do it yourself. I will be teaching you this only. See, you know, P r theta. This is pole. This is psi. This is phi. This is theta. You know it. Tangent normal. PR theta. This is the angle phi. Angle between tangent and radius vector. This is theta. Angle between radius vector and initial axis. And obviously this is psi. The tangent makes with the initial axis. Obviously we have psi equal theta plus phi. Right? Okay. Obvious. Psi is equal to theta plus phi. Exterior angle. Sum of interior opposed two angles. What I have to find is that I have to find rho, radius of curvature, that is in terms of s and psi. So let me differentiate this first with respect to theta. Differentiate with respect to theta. I will have d psi by d theta 1 plus d phi by d theta. Let me call this one. Now let me first find d phi by d theta, which is quite easy. We know from this figure, we know tan phi is r d theta by dr. This is known to us. This is r by dr by d theta. So tan phi is r by r1. Fine. So what is phi? Tan inverse r by r1. Now let me differentiate. I need d phi by d theta. Let me differentiate phi with respect to theta. Now d phi by d theta. Tan inverse function 1 by 1 plus function square. Differentiation of the function r by r1. This is r1 square, r square plus r1 square. Derivative. What is the derivative? r1 square. r1 derivative of r is r1, so it is r1 square minus r as it is, derivative of r1 is r2. So finally this is r1 square minus r2, r square plus r1 square. This is d phi by d theta. Now use this in 1. Hence from 1, d psi by d theta is equal to 1 plus d phi by d theta r1 square r2 r square plus r1 square, or this is r square r1 square r1 square r2 divided by r square plus r1 square. So this is r square plus twice r1 square minus r2 r square plus r1 square. This is d psi by d theta. Fine. Now we will go towards finding rho. Now I have d psi by d theta. I can write it as d psi by r ds by d theta chain r square plus twice r1 square minus r2 r square plus r1 square. Fine. Now what is d psi by ds? It's again 1 by rho. ds by d theta r square twice r1 square r2 r square plus r1 square. So what is rho? Therefore rho is equal to, you can take rho here, this here, r square plus r1 square r square twice r1 square minus r2 into ds by d theta. Likewise in Cartesian coordinates, this was ds by dx, and I had used 1 under root of 1 plus y1 square. Now here I will use it as what? Under root of r square plus r1 square, and I am through. Reason is same. You have to work it out. This is r square plus r1 square is power 3 by 2 divided by r square plus twice r1 square minus r2. If you want to remember it, how this is equal to this, you may see, you may go to the article, then I will, tan phi is r dr by d theta by dr, or r dr by d theta, or r by r1. So tan phi, present beauty, perpendicular. So this is r square plus r1 square. Okay, you can remember it from there. ds by d theta is, this is same way I had shown you. This is p, this is q, and so on. You will do it. And this will be ds. So this will be r square plus r1 square. So radius of curvature for polar form is r square plus r1 square is power 3 by 2 divided by r square plus twice r1 square minus r2. Let me now take up a few questions. Say you have r equal a 1 plus cos theta, R1 minus will be easy because I don't have to take minus sign along with. This is R. What I need to find is that R square, I need to find R1 square. So R1 is to be found out, then R square plus twice R1 square again minus R and R2. So I need R1 and R2. Let me differentiate with respect to theta. What is R1? It is A sine theta. What is R2? It is A cos theta. What is RR2? It is A square cos theta minus cos square theta. R and R2. Now rho. R square A square 1 minus cos theta whole square plus R1 square then again R square again R square but twice R1 square, these two will be same, minus RR2. This is RR2, you have to take minus. So minus A square cos theta minus cos square theta. This is it. Now you have to simplify it only. This is A square raised power 3 by 2. What is inside? A square plus B square minus 2 cos theta plus sine square theta. Now you can take A square outside. This is 1 plus cos square theta minus 2 cos theta. Same here and here. R square and R square. R square and R square. Then you have R1 square. This is again R1 square but twice. So this will be twice. A square you have already taken, sine square theta minus RR2. So minus cos theta plus cos square theta. What is that? See, this is A cube. A cube by A square is A only. This is sine square plus cos square, which is 1. 1 plus 1 is 2. 2 minus 2, which is twice. 1 minus cos theta raised power 3 by 2. Then A square वो तो खत्म हो गया ये. अब cos square, just 2 cos square plus 2 sine square. So it is 2 plus 1 is 3. Minus cos 2 cos theta minus cos theta. So minus cos theta. So 2 raised power 3 by 2 by 3. A 1 minus cos theta raised power 3 by 2 minus 1, which is 1 by 2. So this is the answer. Or you can further simplify it. It is 2 raised power 3 by 2 by 2. Sorry, 3. A 1 minus cos theta is twice sine square theta by 2 raised power 1 by 2. So finally you have, this is okay also, you can keep it here. You don't need to further simplify it, but sometimes you need to further simplify it. 3 by 2 by 3a 2 raised power 1 by 2, and this is sine theta by 2. 2 raised power 3 by 2 and 1 by 2 means 4 by 2, which is 2. 2 raised power 2 is 4 by 3a sine theta by 2. If I would have taken r equal to a1 plus cos theta, answer would have been 4a by 3 cos theta by 2, because instead of 1 minus cos, you will get 1 plus cos, and 1 plus cos is twice cos square theta by 2, right? Similarly, you can do further questions also. Say you have, yesterday we did r square equal to a square cos 2 theta. You can do it. This is 2r r1 a square cos 2 theta. Similarly, and so on. Okay. If we have relation between P and psi, say P equal C sin psi, then your rho is P plus d2P d psi 2. You have to differentiate this twice with respect to psi. This is polar tangent form. If you have relation between P and R, say A square R square, this is P and R. Your rho is R dr by dP. These are two very short articles. You can do it yourself. For example, if you have this question, you can find dP by d psi. It is C cos psi d2p d psi 2. C sin psi. Substitute here and you will get answer. If you have this question, P equal A square, you have to find dP by dr. It is A square to R. So dr by dP is 1 by 2 A square R. So substitute here R and this. So rho R dr by dP. R 1 by 2 A square R. It is 1 by 2 A square, a constant. So likewise, if you have relation between R and P, you will have to use this formula. If you have relation between P and psi, you have to use this formula. If you have relation between X and Y, you know the formula. If you have relation between R and theta, you know the relation. I will take one last question, then this curvature is finished. Let me take R square equal A square, or R is power n. It is power n cos n theta. I will just show you how to find R1 and R2, rest you will do it. Now I have to use find R1 and R2. So this is n, R is power n minus 1 R1. It is power n sin n theta. Differentiating with respect to theta, you will get it. So your R1 is minus n, it is power n sin n theta by n and n cancels out, minus R is power n minus 1. See, if you will do R2 like this, you will be little bit length here. What you will do is that you will write it R it is power n sin n theta by R is power n. R is power minus 1 is 1 by R, which will be R in the numerator, and you know R is power n. So this is minus R it is power n sin n theta. It is power n cos n theta by 1. If this is 1, so you have R1 is equal to minus R tan n theta. Now things will be easier. What is R2? Minus R sec square n theta into n. Then tan theta n theta as it is, derivative of R is R1. Now your R1 is given. So minus n R sec square n theta minus R tan square n theta. So you can take R outside. It is R minus times R n sec square n theta minus tan square n theta. So this is it. This is R2. Similarly, what will be R2? You have to multiply this by R. This will be minus R square. This is R1. Fine. This is R2. What is RR2? Multiply this by R. This is minus R square. N sec square n theta minus tan square n theta. So what is rho now? R square plus R1 square is power 3 by 2. R square plus twice R1 square minus RR2. Now this will be easier because R is involved everywhere. R square, you did not write the value. R square, what is R1 square? Your R1 is in terms of R. So it is R square tan square n theta raised power 3 by 2. Then R square twice r1 square minus rr2. This is your rr2. Minus minus plus. Minus minus plus. And sec square n theta minus tan square n theta. Now you can simplify. R square raised power 3 by 2. Now what remains is 1 plus tan square, which is sec square. Sec square n theta raised power 3 by 2. This is quite easy now. Now r square everywhere. You are having r square over here also, na? R square. So r square outside. 1 plus tan square. Okay. 1 plus tan square minus tan square. What is that? 1 plus tan square. So it is sec square. So it is sec square n theta into 1 plus n. Simply this one. Nothing else. See? R square everywhere. This is r square, na? I have taken it over here as well as here. R square minus rr2. So here r square minus r square. Okay? Now r square I have taken outside. This is 1. Fine? Okay, I have missed. Okay. This is 1. That is 2 tan square minus tan square is tan square. So 1 plus tan square is sec square plus sec square. So this is 1 plus n. Now this is sec cube. This is sec square. This is r cube. So this is r only. This is sec cube and sec n theta by n plus 1. Sorry. This is r 1 plus n secant, which is cos n theta. You see, this is sec cube and sec square. This is only sec, which is cos. This is it. This is rho. You can further simplify it because you know your first question. R is a raised power n. R raised power n is a raised power n cos n theta. So you can find cos n theta. You can substitute over here. Likewise, you can solve each and every question. So I will stop here. I have finished curvature. I will be taking up now asymptotes in my next lecture. Thank you very much.